Hello children, so we are back on videos of probability and this time we are doing conditional probability. But before that, I want you to open our website examprep.world and go to learn and section. There choose the topic of probability and go to type 5 questions, because the questions which we discuss in this video will be in this particular thing. So you have parallel two things, one database of question and one videos. Okay, and this video basically instruction video of the website. So if you are coming through the website, you open there, and if you are coming from YouTube, my request is always open the website parallelly. Okay. Now, what is conditional probability? Now there are two events, right? One event and second event. Now probability of event 1 happening, that second has already happened. Okay. So it depends upon that. So condition, I am giving condition that probability of happening of A provided that B has already happened. Trying to understand? Now something like that, if there is a day and whether it rains or not, right? And if it rains and if it is a Monday. So provided I have given the one condition that it has rained, and then I am asking you what is the probability that it was a Monday. So two conditions, right? So let us simplify this whole process and make it, I'll give you a very simple example. Now I have kept that example here. In a group of 25 students, okay? In a group of 25 students, 15 like milk, 17 like iced coffee, 9 like both of them, and 2 don't like anything. There will be kids who don't like ice or coffee. Me personally, I like milk during the day. Early morning, I like coffee. Okay. Anyhow, so I like both of them. I am in this category. Okay. Now, to find the probabilities, the first task is draw the Venn diagram. Okay. Drawing Venn diagram is easy. So there are only two things. So let me draw the Venn diagram with a different color. I'll use blue color. This is a universal set. This is the set of milk. This is set of coffee. C for coffee. Okay. Now, how many are there? Total 25. But 2 don't like anything. So people who don't like anything is outside. So balance are 23. 9 like both of them. 9. Both of them, it should be in common area of milk and coffee. Now, what about milk? 9 is already here, 15, so it should be 6. Correct? 6 like milk, because 9 plus 6 is 15, and 17. 9 plus 8 is 17. Correct? So now we have the Venn diagram ready. 6, 9, 8, 2. The first question, the first one is very, very easy. Okay. What is the probability that the student like milk? You pick one of the students from those 25 and ask them, what do you like? What is the probability that he says that he likes milk? How many people like milk? 9 plus 16, 9 plus 6, which is 15. And how many students are there? Total 25. So probability will be very simple. It will be 15 on 25, the probability that he likes milk. This is simple. Now conditional probability. I'll move away. Note this up to here. I'll keep moving away from screen so that you can pause videos at that time for you being able to write it. Okay. Now, conditional probability. He likes milk given that he also likes coffee. Okay. Now this is called conditional probability. So if there are two events, probability of A and probability of B, and somebody asks, what is the probability of happening of A that B has already happened? So we write it as probability of A such that B has happened. We put a straight line and we write like this. Now how do you calculate? This is probability of A intersection B, which is common area of A and B, divided by probability of B. Probability of A that B has already happened. So B should come in the denominator. So in our case, he likes milk, that he likes coffee. So it should be probability of milk intersection coffee divided by probability of coffee. Okay, you understood? How do we write conditional probability? There are two events, A and B. Probability of A is something, probability of B is something, probability of A and B is also there. Probability of A such that B has already happened. So here they like coffee, but they should also like milk. So B is already there. B is the first condition, that they like coffee. And then they also like milk. Is obviously 9 upon this whole thing. What is 9? Probability of milk intersection C, the common area, divided by probability of coffee. I hope you understood, right? Pause the video at different stages and think. Draw it on the paper. That is the best thing. If you can draw it on a paper, on your notebooks, you will get it. So what is this? P of A intersection C is 9. And what is probability of coffee? 17. So this is 9 on 25. This is 7 on 25. 25, 25 cancel. It becomes 9 on 17. The final answer is 9 on. See, probability of milk intersection C is 9 on 25. Probability of coffee is 7 on 25. 25, 25 cancels, leaving behind answer 9 on 17. So required conditional probability is 9 on 17. I hope you understood this one. I'll move away, note it. Want me to zoom out or move it little up? I will, that is better. Yeah. Then I'll zoom out. Yeah. Note it now. Done, kids? So let's do some questions from our website. So this is the first question which I collected. There are 28 members of a youth club who went for bushwalking. Read the question. Total is 28. Sunburn, 23 of them got sunburn. 8 got blisters. Oh my God. 5 got both of them. Worse. Very weak kids. Or not very cautious, right? So let's write the data. Total are total 28 sunburn, I will use sunburn, 23 blisters is 8, 5 both of them, together it is 5. So first let us draw the Venn diagram so that we can answer these questions perfectly. 23 plus 8 is 31. Total is 28. That means there are some kids who didn't get sunburn and blister. Okay. This is sunburn. This is blister. Common thing is 5. 23 minus 5, 18. And 3. 5 plus 3, 8. 18 plus 5 is 23. Okay. Now this is how much? 18 plus 5, 23, 26. But total are 28. So 2 kids are outside. See, look. 18 plus 5, 23. And 5 plus 3, 8. So together 23 plus 3, 26. But there are 28 guys. So there are 2 kids who didn't get blister or sunburn. So diagram is complete. Total is 28. 20 plus 8, 28. Correct? Now, determine the probability he got blisters or sunburns. Not and, or. So it is very simple. We go with the straight. 18 plus 5 plus 3. 18 plus 8, which is 26 on 28. Simplify, 13 on 14. The probability is 13 on 14 because it is or. It is not conditional probability. Now second question is got conditional probability. Got blisters that the person was sunburnt. So blister and sunburn 5. So I'll write the formula: probability of blister intersection sunburn divided by probability that he was sunburned. Probability of sunburn. Now if you put the numbers there, you will get your answer. Let us put P intersection S is 5. Total is how much? 28 divided by sunburn is 23 on 28. Cancel 28, 28. You are left with 5 upon 23. So that's your answer, conditional probability. C. Was sunburned given that person didn't get blisters. So for that, this is very simple. Who got sunburned but didn't get blister is this area, 18. So it is straight away 18 upon 28 for third answer. And we had conditional probability, we have normal probability, and we have straightforward answer. Okay. I'll move away from the screen, note it. Let's do the next question. Now, fair hair, blue eyes, European country. In a class of 25 students, 19 have fair hair. Total is 25. F for fair hair, which are 19, and blue eyes, I write 15 are blue eyes. 22 have fair hair, blue eyes, or both. Here you have to be careful. 22 is the union on F of B. But 19 plus 15 is how much? 34. Right? But he says they are 22. 22 subtract 2, 1. The 12 are having common things. They have fair hair and blue eyes. So what I should do, I'll write 12 here. Now we can straight away go ahead and draw the diagram. Which diagram? Venn diagram. Total number of students, fair hair, blue eyes. There are 25 in total. 12 are common here. Now these are 19. 12 plus 7 is 19. See, fair hair is 19. 12 plus 3, blue hair is 15. Okay. Now count this. 15 plus 7, 22. How many students are there? 25. So 3 must be not having either fair hair or blue eyes, just like me in Europe. I don't have fair hair, I don't have blue eyes. Right? So some Asian fellow in this class, 3 guys like me. Rest all are Europeans. Okay. So coming back to our maths. What is the, now you select a guy from there at random. What is the probability that he has fair hair and blue eyes? Very simple, straight away. It is 12 upon 25. Both. Both is very simple. Common area upon 25. Blue eyes, given that he has fair hair. So probability of blue eyes given that he has fair hair. So this should be probability of B intersection F divided by probability of F, which is 12 on 25 divided by fair is 19. 19 on 25, 25 gets cancelled, leaving behind 12 on 19. That's your answer. So pause the video and note it for yourself. So let's move on to the next question. Okay. Mohan Bagan, you know this team is a soccer team from India. It's based out of Kolkata. Okay. Now has 37, they play 37 games this season. The results are shown. So total of this should be 37. Now find the probability at random selected he was one that given it was at home, that means at home country India, or it may be away from, apart from India. So they have given the data, win, draw, and what they lose, right? Probability that they have won. So first we will add them. This should be 17, 13, and 7. This way, in home, 11 plus 5, 16, 19, 12, and 6, 18, 35. But they say 37. Oh no, it is 37. 37. Yeah, 37. Yeah, so our numbers are right. So they have 37. What is the probability that they win the game? 17 on 37. 17 on 37. They won given that it was at home. So here you don't even have to apply your Venn diagram thing, intersection, something. You know that they won, but it was at home. So 1 and home is 11. When you have this kind of diagram, they are better tables, so better than Venn diagram, straight away you can get your answer. At home, given that it was 1. At home, given that it was 1. So here I will do conditional probability, or I'll write conditional probability for both. Given that 1, given that it was at home. So probability of win home. So it is probability of win is how much? So this I should be win intersection home by probability of the game happening at home. Win and home is 11. 11 on 37 divided by probability at home. How many games are at home? 19. 19 on 37. 37 cancels. Answer is 11 on 19. The chances for the first conditional probability is 11 on 19. Now what about this? Was at home given that it was 1. So that is probability of home given that it was 1. See, WH, HW interchange. So it is probability of H intersection W by probability of win. What is home and win? Home and win is once again 11. 11 on 37 divided by probability of win is 17. 17 on 37. So this time 37 cancel, it is 11 and 17. Okay? The method is simple. If you remember this formula, your conditional probability becomes very, very easy. So go ahead and note this one. In a small town, next question. In a small town, there are 3 supermarkets, PQR. What's a small town? 3 supermarkets is big thing. 60% of population shop at P, 36 at Q, 34 at R, 18% shop at this, 15 at P and R, 2 are in all the supermarkets. Probability, a randomly selected person. Now this is PQR, a Venn diagram with 3 circles. Okay, so first let us tabulate the data. P 60%, Q 36%, R 34%. Okay, I have done for P, Q and R. Right. First we have captured the primary data. This is the percentage of population which shop. 18% at P and Q. Common area between P and Q is 18. This done. 15% at P and R. P and R is 15%. These two guys. 4% at Q and R. 4% at Q and R. And altogether 2%. So this is done, and all data captured in a table form where I have clear idea of what is happening in the town. So well, you have to draw a Venn diagram first. 3 circles, 1, 2, 3, P, Q and R. Okay, let me scroll it little bit right side. You see, now the questions are here and this is here and our data is here. So we can fill the data. We will fill the data with a different color. Pink. Okay. So what is common in all 3 PQR? 2. 2%. 2, I have written here 2%. I will not write percent, you know that this is percentages because space is less. Now, between P and Q, it is how much? 18. 2 is already done. So it will be 18 minus 2, 16. P and Q. Look at P and Q, 16 plus 2. P and Q, 18. 18 done, is 2 done. P and R is 15. P and R is 15. 2 is already there, so this will be 13. See the area between P and R, this I. 15, okay, this part also done. Now, 4% between 36 and between Q and R. 2 is already done, so we will write 1, 2. So common area is all included. Now P 60%. How much is this? 16 plus 13, 29, 31. 60 minus 31 is 29. So A part 60% is done. Now 36. Q is 36. 16 plus 4 is 20. 16. Okay. So this part is also done. Q 36 is done. Now R is 34. How much we have? 13 plus 4, 17. Another 17 should come here. So all our percentages have gone inside. Now add them. Always the job is add. So let's add. This is 60. This circle inside 60 plus 35. 95. So only 95%. What about the balance 5%? That means they don't go to any supermarket. So 5 is outside. To understand this, how much you add them, I got 95. 95 is 5% less than 100. That means 5% people don't go to any of the supermarket, they go to the shop next door, which is a good thing. My personal belief. Because you should help the guy who is next door buying things from him. Supermarkets do make a lot of profits buying things from the shop next door. But always you can tell him that keep the nice products. Okay. In a supermarket you have got a lot of variety, and this guy next door may not have lot of variety, but you can always tell them get this thing for me, he will get it. Okay. And that's how we help build a better society. Okay. Now let's come back to the question. None of the supermarkets, our question is answered. It is 5% of the guys who don't go to any supermarket. At P, given that the person shops at least in one of the supermarkets, at least one of the supermarkets is 95%. At P, so probability of A, probability of P, given that at least one. So what is the probability of P? 60 by 100. So it is probability of P intersection all divided by probability of at least probability of all. Okay, at least one is probability of all. At least one. So means he can 1, 2 or 3, he can do anywhere. So sum total of all this. What is probability of P intersection all? 16 plus 2 plus 13. See, it is having only this area. 18, 15, 31. 31 on 100 divided by 95 on 100, which is 31 on 95. First answer. The probability is 31 on 95%. So this answer is done. We'll write it here, 31 on 95. Okay. Now, he shops at R, given the shops at P or Q or both. Shops at R, given that P or Q or both. So that means P union Q. So I will write it as P union Q. Okay, better. So formula is P of R intersection P union Q by P of P union Q. Correct? So formula is done. Now let us write the answer. P union Q. P union Q is all this area. Okay. This whole area. Common with R is only 2. Right? So it is 2 on 100 divided by P union Q is all these numbers. 60 plus 18, 78, 78 on 100. So 2 on 78, it can be simplified to 1 times and 2 39 times. So 1 on 39. 1 on 39. Chances are there that he will do the shopping there. Note it. Now I am going to erase to find the answer for D. Okay. At Q, given that person shops exactly at 1 supermarkets only, probability of Q exactly 1. Exactly 1. So that means 16, 17 and 29, right? 16, 17 and 29. So we can write probability of Q is common with this. Probability of Q intersection exactly 1. Q with exactly one of them. It is 0. So that is, this thing is 0. The probability is straight away, because numerator becomes 0, everything becomes 0. See, he is shopping at Q, probability that he does exactly at 1 supermarket only. So he shops at Q, but he is shopping only at 1. So he is not shopping in any other supermarket. So probability becomes 0 for this one. Okay. So with this, we come to end of conditional probability. I hope you have understood. There are a few more questions in the website. I want you to go and practice. Till that time, thank you. Good luck.